Let's do some sample questions. So, why were no S waves received from this earthquake at some seismic station? So you always want to look. The P waves are drawn like this, the S waves dotted. Answer is, an interior earth layer absorbs S waves. Okay, and that was a multiple choice. That was the answer. Well, I tend to like to say that the S waves can't go through the liquid, but I guess absorbent is also correct. But the S waves can't travel through the outer core. That's how we know the outer core is liquid. Choose the diagram that shows the plate motion. So it showed you this here. It said it was a convergent plate boundary, and it had 4 choices, multiple choices. This was the correct one. And it just shows the arrows on this. So the arrow, the motion occurring at these subduction zones, convergent plate boundaries, are important. Make sure you know it. Here, this shows a diagram of a section of the Pacific Ocean. It goes from A to B, and then this, you should need to recognize that that's a divergent plate boundary. And the question is, complete the graph. And it talks about the age of the ocean floor bedrock, relative age of the ocean floor bedrock. Older is at the top of the graph, and younger, and goes from A to B. And then this is the Pacific Ridge. So you have to recognize and know that the plates are pulling apart and lava's flowing on the ocean floor. This is the newest rock here. As you go here, it gets older. As you go here, it gets older. Therefore, the graph will look like that. Okay? It doesn't jump out at people, hit them in the face, but that is what the answer would be. So hopefully that makes some sense to you. Draw an arrowheads to show the movement in the asthenosphere. Remember convection currents and how they move? Okay, so you have to have a sense of how they move because this is the answer. The arrow should look like that. Okay? Compared to rock C, give the relative age of the rock at D. First, relative age means like compared to. So it's going to be older, younger, or the same age. Now, also know, new rock is formed at these divergent plate boundaries, the Mid-Atlantic Ridge. So as you go this way, the rock gets older. As you go this way, the rock gets older. Therefore, the rock at D is younger than at C. Okay? Which location most likely has the youngest bedrock? See, this is a very similar kind of question with the same basic idea. New rock forms at the Mid-Atlantic Ridge. Therefore, C is closest. So, choice 3. And given in the question was the diagram below shows California. And it says identify the type of plate boundary that's located along the fault. That involves going to page 5 of the reference table, finding California, the San Andreas Fault there. And the answer is transform. Transform plate boundary. So, that's kind of a straightforward one. This, very similar. This is a multiple choice form. What primary geologic process occurring along the San Andreas Fault? Same thing. Reference table, page 5, look it up, and you're going to get transform movement. So those are, if you know how to use a reference table, these are probably some of the easier questions. This, not one of the easier questions. Watch this. What is the color and type of rock that forms oceanic crust at mid-ocean ridges? Light-colored and igneous, light-colored sedimentary, dark-colored and igneous, dark-colored and sedimentary. Hopefully, you know right off the bat that it's not sedimentary and that it is igneous from lava flow. So that you got to know in your head. But the dark color versus light color, that's where it gets tricky. Okay, that's the tricky part of this. So you have to know where are you going to find some information about ocean crust and continental crust. It's here, page 10. It's up here. Let me zoom in, and it's right here on that chart. I'm going to zoom in even more, and it's going to show that it has the density here, but granitic continental crust, because continental crust is mainly granite. Oceanic crust is mainly basalt, the igneous rock basalt. Now you have to know and remember to go to the igneous rock chart of the reference table, page 6, which looks like this. Find basalt. So now we're interested in color. Is it light colored or dark colored? And then you kind of follow down here to this chart, and it has color here. That as you go this way, the rock gets darker. These rocks over here are lighter. Basalt is on the dark side of the chart. So basalt is a dark rock. It's like basically black if you can remember seeing it. So the answer is dark colored and igneous. You had to work for that one. It is in the reference table, but knowing that it's there is very important. And that little section of that chart about the ocean crust and continental crust and the density stuff, you go to that more than you think you would. Mount Reed's seismic activities due to the interaction of which 2 tectonic plates. So this is just which plates. Do you know it's on page 5 of the reference table? Can you find it? This is Alaska up here, and then the plates of the Pacific plate and the North American plate. And therefore, the answer is 3. This one, no S waves arrive directly at seismic station A because some parts of the core are liquid. S waves do not travel through liquid rock. And we see this big S-wave shadow zone that occurs, and that's how we know the outer core is liquid. Know it.